Friends, today we're going to discuss the topic of constructional features of three-phase induction motor, part 2. In part 1, we have discussed the constructional features of the stator of three-phase induction motor. Here we're going to discuss the construction of rotor of three-phase induction motor. The rotor of three-phase induction motor basically consists of two types, squirrel cage type and slip ring type. The squirrel cage type of rotor basically consists of copper or aluminum bars fixed rigidly at both ends by the end rings. So it forms a cage-like construction. This is the side view of it. So the bars are rigidly fixed to the end ring. So this end rings basically provides a short-circuiting nature to the squirrel cage. So the purpose of this end ring is to provide short-circuiting. This squirrel cage rotor is basically is characterized by its cheapness. The construction is very rugged. It's tough construction. So the performance characteristic is very good. We can have good overload capacity for this type of motor due to its rugged type of construction. The maintenance cost for this particular type of rotor is very less. What do we, if anything goes wrong? Generally, that's not the case. But if fault takes place in the rotor, then we take out that rotor and replace it by the other type of cage. And the time required will, that's why, be very less, because there is no winding, so we don't require to do any type of winding. So definitely the time as well as the cost is less for the maintenance. The efficiency of this particular type of motor is really high due to the fact that the resistance is very less, as well as the leakage reactance, because the overhang of this particular type of rotor is negligible. And since the construction is totally short circuited, the overall resistance is less, leakage reactance is less, so hence the efficiency of this particular motor is higher as compared to the slip ring induction motor. Also, another factor for its higher efficiency is that since there are no slip rings and brushes, the friction is very less, and since the friction losses are less, the efficiency is also high as compared to slip ring. Again, since there are no hot spot as far as brushes and slip rings are concerned, we'll have hot spot due to the friction occurring between them, as the slip rings are rotating and brushes are stationary. So the slip ring motor has a larger production as compared to the squirrel cage. So the cooling characteristic is much better as far as squirrel cage type rotor is concerned. And also you can see that the core is smooth, and there are no slots provided for the winding, so the slots generally provide obstruction to the flow of air. As there are no slots in the squirrel cage rotor, the air will flow smoothly over the surface and take away the heat at a faster rate as compared to the slip ring. So definitely the cooling characteristic is much more better in squirrel cage rotor. The bars are short circuited, so it requires no insulation. Insulation requirement is very less, so the cost of the rotor is less, as we don't need any insulation. Similarly, the bars are rigidly fixed to the end ring of the cell. So we use basically thermal fixing of this particular thermal setting of the bars with respect to the rotor. So what we do is that we heat the end rings, which are having the same diameter holes as the diameter of the bars. So due to heating, the expansion of the end ring takes place, and we slide the bars into the end ring holes, and then we allow it to cool. So this is known as the thermosetting process for setting the end rings. So end rings are rigidly fixed to the bars. In order to have a effective or we can say improved starting characteristic, we use a deep rotor bar type of construction. So the bars are in the low, near to the shaft rather than to the surface, which gives us the better starting characteristic. This is the conventional type of rotors, but nowadays the economical type of aluminum casted cylinder alloy type of rotors are also available in the market. So one of the rotor is seen here. It is basically an alloy of aluminum which is casted, and hardly it requires any machining. So there is no machining done on this particular rotor. Surface is very smooth, and since machining is not required, the cost of this particular rotor becomes very very less, and the performance is also good. One thing we can observe in this diagram is that we can see that these there are the slots provided on this particular grooves are provided, little grooves are provided. This is for the fact known as skewing. This is a skewing of the rotor. The purpose of skewing is that the rotor and the stator both are having magnetic fields. The stator magnetic field is rotating at synchronous speed given by the equation 120 F upon P, whereas the rotor will also have frequency magnetic field which are comparatively less as compared to the stator by a parameter known as the slip, due to the slip. But at time what happens is that if by rotation, if we assume that the north pole of the stator magnetic field comes in exactly same alignment to the south pole of the rotor, then there may occur what is known as the magnetic locking. This magnetic locking will cause the rotor to rotate at synchronous speed. And this effect is also known as cogging. This is due to the fact that there are produced harmonic synchronizing torque, which will make this motor to magnetically get locked with the stator magnetic field, running it at constant synchronous speed, which we don't want. So in order to reduce that, there are grooves are provided, and this groove is known as a skewing. So this angle of skewing is generally ranges from 7 to 15 degrees Celsius. So harmonic synchronizing torque we'll be discussing when we discuss the design of the rotor. The other type of rotor is the slip ring rotor. The slip ring rotor basically consists of core, winding, and the slip rings on which the carbon brushes rest. So the construction is a little bit complicated as compared to the squirrel cage rotor. So the slip ring rotor basically has core similar to that of the stator. So the core is made up of laminated silicon steel with silicon having 3 to 5%, or it is also known as the dynamo grade steel with laminations having a thickness ranging from 0.27 mm to 0.35 mm. And basically for having a good characteristics, we use CRGO type of material, that is cold rolled grain oriented, having an advantage that all the grains are aligned in one direction due to the cold process. The other type is hot rolled grain oriented. In hot rolled grain oriented, due to the process which is by heating, the orientation of the grains are not aligned as better as compared to the CRGO. So CRGO is better material as compared to the HRGO in case of three-phase induction motor. Of course, we have discussed this. Skewing is done to avoid the magnetic locking, or it is also known as cogging. There are slots on the outer periphery. These slots are provided to carry the three-phase winding. This three-phase winding is wound with copper conductors. Again, similar to the stator, the slots are multiples of 6 and 6. The number of poles are basically similar. In case of slip ring induction motor, the rotor and stator slots are having the same number of poles. So they will be in the multiples of 6. 2 for the poles and 3 for the phases. The windings may be either star connected or delta connected. Usually the winding is star connected. So advantage of the star connected is that we can connect the one end of each of winding together to form a neutral point, and 3 other points will be brought out onto the slip rings, and then the slip rings can, through the slip rings, the winding can be connected to the external system. That external system could either be a resistance or it could be another supply source depending upon our requirement. for by having this type of arrangement of the winding, the advantage which we get in slip ring induction motor is that we can change the value of the resistance of the rotor, and with change in the value of the rotor resistance we can have effective speed control, and also we can have good starting characteristic. Specifically for the motors which are started using rotor resistance starter, we have to use, or we generally use this slip ring type of induction motor. In squirrel kind of induction motor we cannot have a rotor resistance starter, so rotor resistance starter can be used for star connected slip ring induction motor. The winding is usually wave type because there are lesser number of connections and the winding becomes very compact if we are using a wave type of winding. The next important component from which it derives its name is slip rings and brushes. So there are three slip rings are there in this three-phase induction motor on which brushes rest. The slip rings are usually made up of phosphorus bronze, having since it's an alloy, its resistance temperature characteristic for that specific range is constant. Brass can also be used, but usually phosphorus bronze is preferable. These are again rigidly fixed to the shaft by thermosetting. So we are again using thermosetting process for fixing this slip rings rigidly onto the shaft. The brushes are generally made up of carbon. The following characteristics of the carbon makes it very the only material for the brushes. First one, it is having a negative temperature coefficient characteristic, that is with rise in the temperature its resistance decreases, so the overall rotor copper loss will go on decreasing with increase in the temperature. The coefficient of friction is very low, so it has very less frictional loss. It is softer as compared to the phosphorus bronze, so it will get eaten up more as compared to the slip ring material. So its replacement will be very easy and cheap, because this material is very cheap. So the maintenance cost and time required will be very less. Another added advantage of this particular carbon brush is that it is self-lubricating. Means it, over a period of time with use, its coefficient of friction goes on decreasing. That means it becomes more and more smoother, and the friction will go on decreasing. So here we don't need an external lubrication, because we generally lubricant oils are organic material, and they have a tendency to ignite. So here by using carbon brushes we don't need to do any lubrication, and thus protecting our motor. Thank you, friends. This is as far as the construction of rotor is concerned of three-phase induction motor. If you like this video, kindly do comment, share, and subscribe.